All right, 11F, finding the area under a curve. So this is basically what A, B, C, D, and E have been leading up to. So sorry for that. So if the function is greater than 0, so above the line, we can see that the area under the curve is going to be the integral of that function from B to A. So we work out B, take away A. Now you can see if the function here is below the line and is less than or equal to 0, we can see that the area that it's going to be negative, isn't it? It's going to be a negative value. So we could work out the value from B to A, and it'll be a negative answer. But we looked at this before. That would be the same as working out the area from A to B. So remember, they're negatives of each other. And if we want to work out the area of the shaded region, we have to do it in little bits. So we have to do the value from B to C, and we know that's going to be a positive value. And the value from C to A, which we know is going to be a negative value. So we have to have a negative of that, which will make it a positive. So we have two positives that we can add together. And this is the bit that you're going to have lots and lots of problems with. So determining the area under the curve, the sign is the critical factor. So if it's up here, we've got no problems, it's positive. If it's up here, we've got no problems, it's negative. But what do we do if we want to work out the answer there? That's going to be a positive value, that's going to be a negative value. So you just work out the absolute values, that's going to be positive. Work out whatever value that, assume it's positive, and add them together. So find the exact area of the shaded region. So we've got this bit here and this bit here. So what we're going to do is we're going to work out the area from 4 to 2, which we know is going to be positive. The area from 2 to 1, which we know is going to be negative. So we put a negative there, which ends up making it positive. Okay, so now we're just going to do our notation. Add a power, divide by a power, that becomes 4x. We're doing that from 4 to 2. Plus and a minus make a minus. And then we're doing the same from 2 to 1. We know that that's going to be a negative value, don't we? So this is the value at 4. So this is when x is 4. This is when x is 2. So all of that is when x is 4. All of that is when x is 2. And then that minus relates to that minus. That's when x is 2. So these two things are the same, aren't they? Because that's when x is 2, and that's when x is 2 for that one, and that's when x is 1. And we end up with 37/3. Don't forget the square units. So we can just do the mechanisms of this. But look what happens. If we work out the integral from 4 to 2, which is this bit here, we get the answer 32/3. If we work out the answer from here to here, so negative, we get the answer minus 5/3. So to work out the exact area, we've got to add these two bits together. 32/3 plus 5/3, 37/3, which is what we got when we did this. If we work out the integral from 4 to 1, we get the answer 9. Because basically what the CAS is doing is actually doing this value, take away that value, which gives us 27/3, which is the same as 9. Now, in the previous chapter, we were talking about the total, or the exact value, is where you have to add the bits. And the signed area is where you have to take them away from each other. And your CAS, if you do the whole thing, so if you do it from 4 to 1, the CAS does the signed area. So if you want to do the total area with a CAS, you have to do it in the different bits, this bit first, then this bit first. You have to realize that that'll be a negative, so ignore it and add it. That's what this little bit here is doing. This little minus here is kind of ignoring it because two minuses will make a plus. I know this is the most confusing bit, and sorry that we're doing remote learning, but I'm sure you guys can work it out. There's all the notes. There's the questions, a couple more exam questions. I think that one particularly there is a real horror one, but they're both, the exam questions are getting a bit mean now. Mr. Patch, over and out.